Welcome to my video course on mastering ERTMS ETC signaling systems. I'm absolutely thrilled to be your guide as we unpack what is, honestly, one of the most fascinating leaps in modern railway technology. If you've ever wondered how high-speed trains safely zip across international borders, or how digital computers are taking the reins from traditional physical traffic lights, well, you are in the exact right place. Let's just dive right into the complex engineering of European train control.
Here is our agenda for today. 1. Introduction to ETCS. 2. The concept of ETCS levels. 3. ETCS Level 0 operations. 4. Level 0 driver and system. And finally, 5. The evolution from levels 1 to 3. Let's get going.
Section 1. Introduction to ETCS, Unifying Europe's Rail.
So, think about this. Historically, Europe was relying on roughly 30 completely different, highly incompatible national legacy signaling systems. Imagine you're a train driver trying to cross a border. You'd literally have to stop to change locomotives or somehow equip a single train with a dozen bulky onboard computers just to read the local signals. It was a massive bottleneck. And that's exactly what drove the creation of the European Train Control System, or ETCS, to substitute that scattered legacy tech with a single unified framework.
Section 2. The concept of ETCS levels.
To actually implement this massive continental upgrade, the system relies on a tiered operational framework, known as ETCS levels. Now, these are functional categories defined by two main things: the specific trackside equipment used on the ground and the method by which data is transmitted up to the train-borne equipment. It's a pretty brilliant approach. It means a fully ETCS-equipped vehicle can safely operate across any route because the train's computer just adapts to the specific technical setup of the track beneath it.
Section 3. ETCS Level 0 operations.
Okay, so what happens when a state-of-the-art digital train hits an older track that hasn't been upgraded yet? That's where ETCS Level 0 comes into play. Level 0 is the specific operational context utilized when an ETCS-equipped vehicle operates on a non-ETCS route. It basically acts as a vital baseline compatibility mode. So instead of the train just shutting down or being unable to proceed, the system adapts, allowing the train to continue its journey safely.
Section 4. Level 0. Driver and system.
Now, because the Level 0 route completely lacks ETCS infrastructure, the duties are strictly split between the human and the computer. Because the infrastructure is not fitted with ETCS, the driver's responsibility is huge here. They are absolutely required to observe and follow traditional trackside lateral signals, the physical lights out the window. But for system supervision, the modern technology doesn't just turn off. The onboard equipment remains active in the background to monitor the train for the maximum permitted speed allowed for that specific type of train. So it acts like a digital safety net.
You might notice a bit of an irony here. The whole ultimate goal of ETCS is to make conventional trackside signals totally obsolete and move everything to cab-only signaling. But Level 0 strictly relies on those physical lateral signals. It's essentially a temporary bypass, making sure the railway keeps functioning seamlessly while the continent undergoes this massive multi-year upgrade.
Section 5. Evolution. Levels 1 to 3.
Let's step through how this technology evolves as we start introducing active trackside equipment. Step 1 is Level 1, which uses spot transmission via Eurobellies superimposed right on existing signals. Step 2 leaps to Level 2 with continuous digital radio via GSMR, using virtual signals. And Step 3 is Level 3, which dynamically calculates safe distances using moving block radio spacing. Notice how, as we progress through these steps, fixed trackside signals are completely eliminated.
To break that down a bit more, in Level 1, Eurobellies is placed on the track provide spot movement authorities to the train, though fixed signals do remain. Level 2, which is the standard for today's high-speed lines, replaces those traditional signals entirely with virtual ones on the driver's interface, continuously tracking trains via a radio block center. Then Level 3 is the absolute pinnacle, full radio-based moving block spacing. Trains calculate their own absolute braking distances, meaning they can run much closer together, which massively increases line capacity. It's a real game changer.
So from a fragmented patchwork of incompatible national networks to a unified digital moving block reality, ETCS is fundamentally rewriting the rules of railway engineering. We've seen how legacy systems are safely bypassed in Level 0 and how the technology scales to handle unprecedented capacity up through Level 3. But as these systems become increasingly autonomous and reliant on continuous data streams, it raises a critical question for the future of infrastructure. As the physical signals vanish, how vulnerable does our digital railway become? Thanks, we can see you next video.